Okay, we're on problem 186. And 186 says drum X is half full of oil. So here's drum X, and it's half full of oil. And then we have drum Y, which has twice the capacity of drum X, and it is 2/3 of the way filled with oil. So 2/3 of the way filled with oil. If all the oil in drum X is poured into drum Y, then drum Y will be filled to what fraction of its capacity? Well, let's pick some numbers. So whatever X is, well first of all, we look at these percentages. We should probably pick some numbers that would divide into these evenly. So let's pick 6. Why not 6? So let's pretend that drum X can hold 6. That's its total capacity. Well, the question tells us that Y has twice the capacity, so Y can hold 12. Okay. Well, it's half full. X is half full, so that means there must be 3 units of oil inside X right now. And if Y is 2/3 of the way full, then Y must contain 8 units inside. So if the 3 gets moved over to Y, what are we going to get? We're going to get 8 plus 3 equals 11. There's going to be additional oil in here that's 11 units out of a possible 12. So the answer is going to be 11 over 12. And this is going to be true, well, this is C first of all, but it's going to be true regardless of what numbers you pick. Because if we had picked a larger number, what would happen is we would get a different ratio, but then we could simplify it by dividing both the numerator and the denominator, and we would eventually simplify to 11 over 12. But 186 is C. 187 says if x is larger than 0, and x over 50 plus x over 25 equals what percent of x? Well, whenever we deal with percentages, we want the denominator to be 100 because then we can just look at the numerator and figure out what percent it is. So 50 and 25, let's turn this into 2x over 100 plus 4x over 100. We add these together and we get 6x over 100. Well, what do you know? Percentage, 6%. And that is answer A. 188, if the operation, and it looks like a little snowflake, Operation Snowflake is defined by all A and B by the equation A snowflake B equals A squared B over 3, then we're going to be looking for 2 snowflake 3 snowflake negative 1. First thing we want to do is figure out this so that we can snowflake it by 2. So if we snowflake the 3 and the negative 1, we plug it into this equation and substitute the A and the B, and we get 3 squared times negative 1 over 3. Cancel out the 3 and we get negative 3. So then let's rewrite this equation as 2 snowflake negative 3 and plug it into the equation a second time. Second time around, what do we get? Well, we get 4 times negative 3 over 3. Cancel these out, and you're left with negative 4. And negative 4 is answer E. Okay, on to number 189, which says the inside dimensions of a rectangular wooden box are 6 by 8 by 10. So here's the box. It's 6 by 8 by 10. And they say that there's a cylindrical canister. So we have a little cylinder here that we are going to place inside this box, like so. And they are asking, what would the radius be? So we're going to be looking for radius. What would the radius be of this cylindrical cylinder, this canister, that would be placed into this box? we're going to be trying to maximize the volume. So max volume. So we're looking for the maximum volume, the radius that would create the maximum volume and would still fit inside this box. Okay, so we're going to have to do, let's make a chart and figure out what all the different possibilities are. So the radius, the radius is, 2r is going to be diameter, right? So let's work with diameter. So we know the diameter is going to hit some limits. If it were to go in now, like the way that this box is drawn here, it would be limited to 8, because if diameter was 10, it wouldn't fit because the length is 8 and it wouldn't be able to fit in. So it's limited by the side that has the smaller number. So if this canister were to go in now, the diameter would be 8 and the radius would be 4. Well, the diameter would be 8, but then we're looking for volume, and so the height would be 6, right? So then height equals 6, radius equals 4, and we know that the volume is going to be height times the area of the circle at the top. So area is going to be pi r squared. 4 squared is going to be 16. Pi times 6 is 96 pi. That's going to be the volume if we were to put in the canister as it is now. The other way that we could insert this canister is if the box were drawn so that it was 8 by 6 by 10. In that case, this cylinder would be limited, would have a limited diameter of 6, because 6 is now the short side. And it would look like diameter would be 6, so the radius would be 3, and the height would be 10. Radius, again, we plug that into pi r squared to get the area, and we get 9 pi times 10. That's going to be 90 pi. So that's actually smaller. Let's see, what else could we possibly have? Well, we could have a third situation where the box is 8 by 6 by 10, but just by looking at this, we know it's not going to be larger. It's going to be smaller, because this diameter, the height is only going to be 8, but the radius is still going to be limited to 3, and so it's definitely going to be smaller than 90 pi. So look, based on these drawings that I've done, I would say that 96 pi is going to be the largest volume you could possibly have in a cylinder that goes inside a box. And what that means is then the radius is going to be 4. And that is answer B. So yes. 190 says, what is the units digit of 13 to the 4th power times 17 to the 2nd power times 29 to the 3rd power? Okay, you're probably looking at this and thinking, man, I'm going to have to do 13 times 13 times 13 times 13. This is going to take me a long time to do. Well, remember that the question is only looking for units digit. So what that means is we don't even need to care. We don't need to care about any of this other stuff. We just need to take the units digit and figure out what that's going to be. So 3 times 3 times 3 times 3, what is that going to be? 3 times 3 is 9, times 3 is going to be 27, and 27 times 3, that units digit is going to be 3 times 7. It's going to be 21, right? And we only care about the units digit, so it's going to be 1. 17 squared, we only look at the 7. 7 times 7 is 49, and the units digit is going to be 9. 29 times 29 times 29, we only look at the 9. 9 times 9 is going to be 81 times 9. 9 times 1 is going to be 9. So we end up with 1 times 9 times 9. That's going to be 81 times 1. And again, we only look at the units digit. So the units digit is going to be 1. And that is answer E. (191). Okay, so we have Avenue A, Avenue B, Avenue C, and then we have 4th Street, 3rd Street, 2nd Street, and 1st Street. And then we have a dot here, and a dot here. This is X, and this is Y, and a line that looks like this. And then Avenue A is here, Avenue B is like that, and Avenue C is here. So the problem says Pat will walk from intersection X to intersection Y along a route that is confined to the square grid of 4 streets and 3 avenues shown in the map. How many routes from X to Y can Pat take that have the minimum possible length? So what they mean by minimum possible length is this. If this guy started here, he needs to get from X to Y by walking the smallest distance possible. That's going to be like going up and up and up 3 blocks, and right 2 blocks. He is not going to go up, 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 right, down, left, down, right, up, up, up. So basically the question is saying he's going to go up 3, so up 3, and right 2. And we're trying to figure out all the different ways that he could possibly do this. He could go up, 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 right, or he could go up, right, up, up. It would still be 3 ups and 2 rights. He could go right, up, up, or he could go right, up, right. So there's a lot of different possibilities. This is another one of those figure out all the different combination type of questions. So how do we solve this? Well, we know that in total he's going to be walking 5 blocks. So, 3 plus 5, that's going to be 5. 5 blocks. We're going to actually use factorial to figure out what are all the different combinations that he could have between ups and rights. Well, we know he goes up here once. He goes up here, and he goes up here. So there are 3 ups. So we need to divide by 3 factorial. And the reason why we're doing that is because when we're putting together all the different combinations, we don't care that he went up here at this particular time. Because this up is just one of many ups. The way that we're counting the ups is just the fact that he went up. We're not saying that he went up specifically on this street because we're counting all these different ups as well. So we put a 3 factorial on the bottom of the equation so that we can eliminate all the times that we sort of overcount. The same goes for the fact that he goes right 2 times. It doesn't matter where he goes right 2 times. It's just the fact that he makes 2, he goes right twice, wherever the case may be. So we're actually going to multiply by 2 factorial as well. What happens when we do that? We get 5 times 4 times 3 times 2 times 1. On the bottom we get 3 times 2 and times 1. Also we get 2 times 1. Well, those cancel out. That cancels out. This becomes 2. 1 cancels out. 2 times 5 is going to be 10. And 10 is going to be answer C. Now the other way you could have solved this, of course, is you could have drawn out all the different possibilities. I'll do that for you right now, but you'll see how sort of unintuitive that is and how much time it would take. So we know he goes up 3 times and right twice, right? So you could write U, 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 R, R, U, U, R, U, R, U, R, R, U, U, R, R, U, 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 R, U, U, R, R, U, U, R, U, 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 R, R, U, and U, R, U, U, R, and U, R, U, R, U, and R, U, R, U, U. So yeah, I mean, there's 10 different routes, and you'd have to figure this out, and then you have to make sure you didn't recount an original one, and it's just kind of a mess. So stick with the factorial method. It's much easier. Anyway, I think I've exhausted my time, so I will see you in the next video.